Hello, I am Jim. Recently, we discussed the different connectives. Now, we are going to discuss how to determine whether a a compound proposition connected by connectives is true or not. For that, we use a truth table. So first in the truth table, we have to input P and Q, the different propositions involved. And then we will add the different compound propositions. So first, we have to add the truth values of P and Q. Now the truth values are of course true and false. However, so there's two, right? And then we'll have to add raised to n. Now n is how many propositions are included. So the propositions are P and Q, so it's 2 raised to 2. That gives us 4. 4 propositions. It means there are 4 possible combinations we can make. So I will start. For P, and this goes for usually what you could do for your first proposition is you write it like this: true, true, false, false. You put all the truths to the start and the false at the next part. Now for Q, you input it like this, alternating true, false, true, false. Now, first we have the conjunction P and Q. Remember, it is only true if P is true and Q is true, if both statements are true. So in the first row here, we can see that this is true and this is also true. So this makes this row true. The second row is false because both are not true. The same goes to the third row and the fourth row because both are false. Now, P or Q, disjunction. This is only true if at least one is true. So the first row is true because both are true. The second row is true because at least one is true. The third row is true because at least one is true. But the fourth row is false because neither are true. Remember, for disjunction, it is true only if the two propositions are true. Now for exclusive OR, for XOR. The exclusive OR is only true if only one is true. So the first is false because both are true. Has to be only one. The second row is true. The third row is true because for the second and third row, both have only one true statement. The last row is false. For implication, P implies Q. You can see here that it is only false if the first statement is true and the second statement is false. We can already spot one here. The first statement here is true and the second statement here is false. So that makes it false. If it is not in that order, then it is true for implication. For biconditional, it is true if both statements are true or false. So in the first row, since both are not true or false, it is false. Remember, both have to have the same truth value. That means the second row is true, the third row is true. Oh, now here's a common issue with these truth tables. When you formulate the truth table and you're doing the different values, you always have to look at the first rows. This best explains it. Especially for truth values, you have to make sure of this, because if you make one mistake at the start, it will affect your solution entirely. So P applies Q. This is true because the first statement is true and the second statement is true. This is false though, because it follows the T and F arrangement. The first statement is true and the second statement is false. This is true because it is not, and same with this. As for this last one, the biconditional again, here, only the last and the first rows are true because both have the same truth value. False, false, true, true. Because the rest are false.